Our rabbit population starts with 4 rabbits and increases at a rate of n prime of t rabbits per week. What does 4 plus the integral from 0 to 26 of n prime of t dt represent? Okay, let's see. So that 4 is the initial population. And then the integral from 0 to 26, so this is integrating a rate of change, and I know that that always represents a actual change, and so this is the change in population from t equals 0 to t equals week 26, so the first half of the year from the start of this experiment. And so then if we add these two things together, that means that the entire symbol, you start with 4 and then you add however many rabbits you gain or lose. But the final answer then is the actual rabbit population at time t equals 26 weeks. So at that one moment in time, the whole expression represents the population then. Part B, if n prime of t equals e to the t over 10, how many rabbits will there be after a year? Okay, so I know that after 1 year, I should do essentially the same calculation that's up above, but instead of 0 to 26, I need the whole year, so that's 0 to 52. And then instead of n prime of t dt, we'll put the specific function here, e to the t over 10 dt. And again, the 4 plus is going to account for the original population. And once we do this integral, that's where the bulk of the work is on this problem. That will tell us how many rabbits we gain or lose. Add that to the 4, and we'll figure out how many rabbits we have after 1 year. Equals 4 plus. Okay, this integral feels like we need a technique. And the integral of e to the t over 10 is going to be a u substitution. We're going to let u equal the exponent. And then take a derivative of that thing. So the derivative of t over 10, you could use the quotient rule. Please don't. T over 10 is the same as 1/10 of t. And the derivative of 1/10 of t is just 1/10. Don't forget the dt. We'll solve this thing for dt by multiplying both sides by 10. And now we've got all the pieces we need to go back up and substitute. So integral, instead of e to the t over 10, it's e to the u. Instead of dt, it's 10 du. But we don't get to put 0 in 52 because we're doing everything in terms of u now and not t anymore. So we'll do this over here on the side. If t equals 52, then u equals something. If t equals 0, then u equals something. So we know our definition for u. You just take t and divide it by 10. So that's what we'll do. T equals 52, divide by 10, the corresponding u is 5.2. When t is 0, divide that by 10, it is still 0. So we put 0, and we put 5.2. And now after we do the integral, we don't need to go back to t's at the end of this problem. 4 plus. Okay, that 10 is a constant multiplier. It comes outside the integral. The integral of e to the u du is simply e to the u plus a constant. But in this case, we're not doing that. We're doing a definite integral from 0 to 5.2. And as I just mentioned, we don't substitute back in for the t. We just plug in 5.2 and 0 for these u's right here. 4 plus 10 e to the 5.2 minus 10 e to the 0. And so we just type this thing into the calculator. I guess I'll do that here. Four plus 10e. Oh, that's not the one I wanted. 10e to the 5.2, and then close those parentheses, and then minus, and then e to the 0 is just 1. So we just subtract 10 at the end of this. About 1807.